building finds there is a 38-degree angle of depression to the head of the assistant, who is 170 centimeters tall. So there's your angle of depression. Remember, angle of depression is always measured from a horizontal line. Okay, it's like if you were looking straight ahead and you turned your head down. That's your angle of depression. The assistant is 170 centimeters tall. If the assistant is 10 meters from the building, how tall is the building? Okay, so this is another one. This is similar to that rocket ship problem that we did on yesterday's homework. We're going to be able to do trig to find this piece of the building. Okay, because we've got this triangle here where we can find this piece of the building. And then we're going to have to add this piece on later. Okay, because that's not part of our triangle. But luckily, that's really easy to add on because it's exactly equal to the guy's height. Does that make sense? Okay. Now, if this is my triangle, my problem here is I don't have an angle in the triangle. What can I do? Alternate interior angles? Yeah. This 38 degrees could be moved down here. So this would become 38 degrees. So this is my angle now. And I have this side and this side that I'm working with. So what trig function is going to work with that? What's trig function with this side and this side? Tangent, yeah. So I'm going to set this up as tangent of 38 equals, and from the 38 I would do opposite over adjacent, so that would be x over 10. Okay, sorry, you can't really see my 10 there. Help me out with tan of 38 from your calculator. 4 decimal places, please. Thank you. 0.7812 equals x over 10. And what do I do from there? Cross multiply, yeah. So you're really just doing 0.7812 times 10, which is going to be like 7.8. That's 7.8 meters because this measurement here was in meters. So now I need to add the guy's height onto there to add this little chunk of the building. Why can't I just add 170 directly? It's in centimeters, okay? But centimeters to meters is pretty easy, okay, because there's 100 centimeters in a meter, so you can convert by just moving the decimal 2 to the left. Okay, 1, 2. This would now be 1.7 meters, and I would add that here. And I think that's going to be 9.5. So the height of the building is 9.5 meters. Good? Questions on that at all? Okay. What else would you like to go over? 3.5. Not going to happen. Kyle? 16. 16? Okay. 16. The base of a 24-foot ladder is placed 8 feet from a building. So here's your 24-foot ladder, here's your 8 feet from the building. First question I'm asked is, what angle does the ladder make with the ground? Make sure you're looking for the right angle here. It's where the ladder meets the ground, so that would be this right here. Okay, this is my angle that I'm trying to find. Again, remember that symbol is just like using an X. If you use an X there, that's fine too. But that's just sort of how you mark and say this is the angle I'm trying to find. Okay? All right, what trig function would work with this side and this side from that angle? Which trig function is that? What's this side compared to that angle? That's adjacent, and this is the hypotenuse. Adjacent and hypotenuse is cosine, yeah, cosine. So I would say cosine of theta is equal to adjacent over hypotenuse. So that would be 8 over 24. And then this is where you're going to type into your calculator cosine -1, or second cosine of 8 over 24. Do you have it, Isaac?
70.5.
Say it again?
70.5.
70.5. Okay. Good. Then it says, how high above the ground is the top of the ladder? So what that's asking for is this distance here. Okay. So now I want to know this. I see two different ways I could go about that. If I were to do it with trig, now I know that this is a 70.5 degree angle. I want to involve the opposite somehow because I want to make sure I have my x in my equation. But then I could use either the adjacent or the hypotenuse. It doesn't matter which one. So if I have to use the opposite, which two trig functions do I have to choose from? Yeah, so I could do tangent or sine. What do you feel like? Sine. Okay. So I would say sine of that angle, which we now know is 70.5 degrees, is equal to opposite, which is x, over the hypotenuse, which is 24. Everyone okay with that setup? Can you help me with sine of 70.5? Thank you. 0.9426 equals x over 24. Put this over 1 and cross multiply. So you're really doing 0.9426 times 24. It's probably going to be in the 20-ish range. 22.6? Thank you. So that'd be 22.6 feet. Let's do one more together. Emily? 13? Okay. 13. There was one very similar to this in your notes for number 13, except this one is asking about an angle of descent instead of an angle of ascent. Okay? This wants to know the plane is flying along here, and it sees that the airport is over here, and it wants to start descending. So what angle does it need to turn at? So remember, it's flying along horizontally, and it wants to turn this way. So this is the angle that I'm trying to find. Okay? It's 33,000 feet up in the air right now, and it's 130 miles away from that airport. So, what do I do? Yep. Yeah, that's exactly what I would do. Is this angle is going to be the same as this angle, right? So I'm going to put that angle down in my triangle. And then which trig function do I want to use? Okay, I'm going to use tangent. Actually, I forgot something first, though. Yep, I need to convert either miles to feet or feet to miles. I'm going to take this one and divide by 5,280. Actually, you're going to take this one, divide by 5,280. So 33,000 divided by 5,280, 6.25. And now that I have those in the same unit, now I can set up tangent of theta is equal to opposite over adjacent, so that'd be 6.25 over 130. And then let's do second tan of that divided by that. Anybody have it? 2.75? That sounds about right. Okay, it's going to be a really tiny angle. Planes are not going to descend at a 45-degree angle. That would be terrifying. Okay? Questions on that?